In this video, I will show you how to determine the percent yield in a reaction. So percent yield, and what a percent yield represents, it is basically the ratio of what you actually collect versus what you should collect if the experiment goes perfectly, which usually doesn't happen. So I'm going to give you the formula to determine the percent yield of a reaction. So, as I said, the percent yield will be actual yield over the theoretical yield. Theoretical times 100, because it is a percentage. So I talked a little bit about theoretical yields in the previous video on limiting reactants, and you will use when they ask you for the percent yield of that reaction, you will most probably use that theoretical yield over one that they will give you, which would be the actual yield. And well, before I get started on showing you how to obtain it, let's talk a little bit more about what actual and theoretical yields are. So the theoretical yield the theoretical yield is simply the product yield, assuming there are no errors, assuming it's a perfect reaction, that there are no errors like committed throughout the whole process. That usually never happens. There's always like human error or any kind of error that occurs. So this would be the product yield, assuming no errors were made. And now the actual yield is what as its name says, what you actually collect, the product physically collected by the experimenter. So product collected. And something you really have to know is that the actual yield should always be lower than the theoretical yield. I mean, you cannot collect more than what perfection could collect. You cannot collect more than what will happen if the experiment were perfect. That's just physical. That's just impossible. So I'm going to write actual yield with AY should be less than theoretical yield. And be sure to remember this. This is very important. Now let's get back to our equation. So we have percent yield would be actual yield over theoretical yield, right? Times 100, because again it's a percentage. So I'm going to use the same information I used for the limiting reactant problem in the previous video, and you will usually be given what the actual yield is, and they will ask you what the percent yield is. So they are telling us that the scientist collects 15 grams of 15 grams of Na3PO4 or sodium phosphate, and they want us to determine the percent yield. And what we obtained from the problem that we solved last time was that the theoretical yield was equal to 24.31 grams. Don't get confused at this number just because I got it from nowhere. We actually solved this problem in the previous video. So you will determine this. But this will be given, which is the actual yield. Now you simply have to plug it in the equation. I'm going to write it here. Let me make it a little rectangle. So the percent yield would be equal to, as you may notice, the actual yield is smaller than the theoretical yield, so we're fine with that part. So it'll be actual yield is 15 grams, and theoretical yield is 24.31 grams. This means that the grams will cancel, and this will multiply by 100. So we're going to get that 61.7%. So this is our answer for our percentage yield. Well, scientists strive to get 100% yield, which would be a perfect reaction. And again, it's really, really hard for it to occur. You usually need like very optimal machines and everything just running perfectly. But this is you consider it a high yield. There's always error. Remember that, and that is how you obtain the percentage yield of the percent yield of a reaction.